Algebra 2 trig pre-college inequality video. What is the solution set of the equation absolute value of 3 minus 2x equals 5? The way to solve an absolute value equation is you're actually going to solve two equations at once. So what's inside our absolute value bar is 3 minus 2x. That's going to go in the middle between two equal signs. And on the right side, you're going to have it equal to 5, which is what we see over here. But on the left side, you're going to have it equal to negative 5, the negation of what was over here. So one equal to what it is, one equal to the negation of what's over here. And if there's an expression over here like x plus 2 or something like that, we would negate that whole thing to be negative x minus 2. So whatever's over there, it's the negation of that. And now you solve this equation, but you're kind of working both ways. So the first thing I want to do is minus 3. Well, I minus 3 to both ends of that as well. And so that's going to give me negative 8 equals negative 2x equals positive 2. And then to get x alone, I'm going to divide everything by negative 2, and divide by negative 2, divide by negative 2, and I end up with a positive 4 over here, x, and also a negative 1. And so at this point, I can now separate it to say that x equals negative 1 and x equals positive 4. You definitely want to check these, even if it's just kind of a quick look at it. So let's see, if x is negative 1 here, that would imply negative 2 times negative 1 would be positive 2. And 3 plus 2 is 5. The absolute value of 5 is 5, so that checks out good. And let's try a 4. Negative 2 times 4, if this was a 4, that would be negative 8. It'd be 3 minus 8, which is negative 5, but it's the absolute value of negative 5, which is positive 5, so that works as well. So negative 1 and 4 are your answers. All right, so this is an inequality video, and this clearly is not an inequality. It's an equal sign, so it's an equation. But that's just kind of getting us into the absolute value. So now we see an inequality symbol. And this is the symbol for less than. Kind of looks like a squished L. And the bar below it means equal to. And we'll also see greater than and so on. So the way to do this is very similar to what we did with the equal sign. That we're going to have 2x minus 3, what was between our bars, in the middle. But this time, instead of in between two equal signs, it's going to be in between two less than or equal signs. And equal to 1, which is what we have over here, and on the left end, negative 1. And we solved this just like we did in this previous problem. And so we're going to add 3 on both sides. So adding 3 everywhere is going to make this 2 less than 2x less than or equal to 4. And then dividing everything by 2 is going to give me 1 less than or equal to x less than or equal to 2. And so that gives us the answer of C. And so it's very similar to an equation with an equal sign. We just have to always be careful that when we're working with inequalities, we have that one special rule. If you remember that, anytime you divide by a negative number, you have to flip your sign. So if it's less than, it'll turn into greater than. And so on. That didn't come up here, but say this was like a negative 2x, we'd have to change all these less than signs to greater than signs. But that didn't happen in this problem. But we always got to be on the lookout for that when we're working with inequalities. Other than that, we pretty much treat it like an equal sign. All right, let's look at another example, except this time the big difference is that this is a greater than symbol. And so we can't do what we've been doing by, putting the negation of 1 on the left and 1 on the right in between. It doesn't work for greater than. For greater than, you're going to end up with two completely separate inequalities. You end up with 4x plus 8 is greater than 16, which is exactly what this is, just removing the absolute value bars. And then you also end up with 4x plus 8, so not changing what's in here at all, but this time it's less than negative 16. And so that's a little bit different. Instead of having kind of one equation all put together when it's greater than, we have this, and this is actually going to create an OR statement, we call it. And so you solve these. This one in red, let's see, we would minus 8, make it 4x is greater than 8, and divide by 4, so x is greater than 2. And this blue equation, when you would minus 8, you'd get 4x is less than negative 24, and x is less than -6. And so you end up with two completely different inequalities, but you would combine them with an OR symbol. And so you have x is less than -6 or x is greater than 2. And what that means is if you pick any numbers less than -6, like -10, -12, -13, and plug it in here, it's going to work. And if you plug in any numbers greater than 2, like 7, 9, 14, it's going to work. So that's why the values of x are on both sides. Now, if we were to look at this on a graph, and some of these questions ask for graphs, just to jump ahead a little bit, I'm not going to do these problems down here, but inequality graphs and so on, like this next problem, which we'll see tomorrow in class. When it's less than, like this previous example of 1 to 2, you would see it would be 1, 2, and you'd have the circles here. Now, these would be closed-in circles because of the equal to bars. And less than, we see a bar connecting in between. That's saying that x is everything between 1 and 2. But in the scenario of greater than, like in this case, we would have -6 and +2. Now, these are going to be open circles because we're not also equal to. But instead of a bar connecting them, you'd see that they would have arrows away from each other, meaning like this is saying x is less than 6, and this is saying x is greater than 2. So that's how you would do the inequality part of it. Okay, so that's absolute value inequalities. And then lastly, real quick, I also want to discuss a quadratic inequality, but it's very similar. Basically, you're going to factor it. And you kind of want to know that when you see a less than sign here, that's a big hint that it's not going to be an OR statement. The less than is x between numbers. The greater than are where we get the OR statement. So especially when it's multiple choice, that kind of narrows it down for you. But you want to factor this, and if it's not set with 0 on the right side, then you want to set it with 0 on the right side. But this would factor to x minus 3 and x plus 2 is less than 0. And just like we do with quadratic equations, then you basically solve each factor with that. And so you end up with x is less than 3, and x is, actually, this isn't going to work this way. Quadratics, for the absolute value, it's easy to keep it an inequality sign, but for the quadratics, honestly, I don't want to confuse you here, but when it comes to quadratics, I'm going to not think of it as an inequality for the moment. I'm going to think of it as an equal sign. So I'm going to temporarily change it to an equation because that would give me answers of 3 and answers of -2. And so these are my critical numbers, we would call them. -2 on the left and +3 on the right because they go in number order. And then the fact that it's a less than sign tells me that I'm going to be between the two of them. And I'm also going to be open circles because I'm not also equal to. And so that's why the answer here is D. So when it comes to quadratics, I do feel it's just easier to think of it, you have to use the inequality sign to determine if it's going to be between statement or an OR statement. But to get the critical numbers, it's easier just to think of it as an equal sign and go from there. All right, this next question, number 5, is where you're going to start tomorrow in class. See you later.